I'll turn over to Neil from Currencycloud. Neil, over to you.
Thank you, Fernando, and nice to have the opportunity to speak to you all today. My name is Neil Drennan. I'm the Chief Technology Officer at Currencycloud. We were acquired by Visa in December 2021. We provide access to virtual named accounts for our customers to enable them to collect, convert, pay, and manage multiple currencies globally. And we try and do that as efficiently as we can. And as part of that, we obviously build and design highly available and resilient systems. So normally this topic, I guess we could spend a day on this topic, but we're not got the time for that. So today's just going to be a sort of very top level run through of some of the things that we do at Currencycloud, and excited to share them with you. So I'll start with a quick intro to Currencycloud, a bit of a high level architecture. Then we'll go into some of the things that we do around resilience by design, and then I'll step you through some of the work that we've been doing on cross-region disaster recovery using AWS. This is kind of the Currencycloud high-level architecture. It's pretty standard, I would say. We have a direct application, which is a front-end UI, which FX brokers can use to access our platform, but most of our traffic comes in via API. Through a content distribution network, we use Cloudflare into an API gateway, and then into our main platform, which is predominantly Java event-driven microservices running on Kubernetes with Istio as the service mesh. We take a domain-driven design approach and have sort of ruthlessly applied inverse Conway's law to it. So we have teams aligned to those specific domains. Examples here being FX, payments, collections. Those are underpinned by a treasury function, and of course compliance for transaction screening, monitoring, and compliance operations. We integrate into a range of third parties that we use an adapter pattern for, and we use Kafka extensively across the platform with Confluent as our managed provider for that. Monitoring and alerting is predominantly with Datadog, with PagerDuty, and FireHydrant for incident management, and then Snowflake for some of our analytics and MI. So this is, I think, a pretty standard architecture. Sort of everything's running on AWS. We use EKS for running our kube service within AWS. We use AWS Aurora Global DB for cross-region replication of our underpinning data. We're on the MySQL variant of that. And then there's smatterings of Elasticache, OpenSearch, etc. within the rest of the stack. So how do we ensure our platform is highly resilient? A number of approaches. So firstly, we have a common model microservice, which implements patterns around observability, outbox patterns, and adapter patterns, so that our developers aren't reinventing the wheel every time they come to implement a new service. We centralize those through a DevX team, and we obviously robustly test them for security and resilience recoverability. We leverage tooling wherever possible across the development community. So again, common underpinning technologies provided by AWS. EKS, we run in 3 availability zones as standard, with anti-affinity rules to ensure that our services are deployed in each of those AZs, and priority classes to ensure that in the event of a node failure, the right key services kind of come up first and are scheduled by the kube scheduler initially before some of the lower priority services come up. As I mentioned, AWS Aurora Global DB, we have 47 database clusters. We separate out our tier 1 services across independent DB clusters, again for availability and resilience reasons. But some of the lower tier services that aren't so critical, we share DB clusters for those for cost reasons. We use cross-region async between Ireland and London, and I'll show you some data in a few moments around how quick that async replication actually works in practice. Istio as the service mesh, and then monitoring and alerting via Datadog. We automate a whole range of best practices in the pipeline. So we do component non-functional test with a tool called K6. K6 is an open source piece of software that enables us to performance test and stress test our components. The hooks are all in the pipeline for our developers to use that on their individual services. and it's actually a gating factor to be able to promote through our environments that you are within certain performance boundaries of the given service. We enable chaos tests in the pipeline also, but this time we use Gremlin API. Gremlin is a commercial off-the-shelf chaos engineering toolset that enables you to do a whole variety of failure scenarios, everything from kind of blowing the CPU up or doing a black hole attack where you remove all network, or you can introduce packet loss or network latency on a given link. And that can cause a whole raft of great scenarios to be able to test against the platform for its resilience. And then in terms of processes, it's not just about the technology and the stack that we're using. We embed the processes into the team. So we use fault mode effect analysis for all of the teams to systematically look at how the platform could fail, what the impact of that would be if it was to fail in that given scenario, to drive out what's called a risk priority number, which is a function of the severity of the impact and the likelihood of that scenario occurring. And that helps drive prioritization in terms of the areas that we choose to fix. FMEA, there's some great talks by Adrian Cockcroft on FMEA. If you want to go and look at it, Adrian and his team were the guys that originally created Chaos tool sets over at Netflix and the OSS team. And then finally, we embed weekly chaos engineering exercises company-wide across Currencycloud. These are quite fun. So every week between 9 and 11 on a Friday morning, we, in a non-production environment that's sized equivalent to production, run production traffic simulated on that environment. We then don't tell the teams what we're going to do, but we kick off a series of tests once we're in steady state. And we really observe kind of how long does the system self-heal in those tests. If it doesn't, what's the mean time to detection from the team? And then ultimately, what is the mean time to restore given that scenario? We try and make it quite a fun exercise. No one really knows what's going to happen. And outside of the test being completed, we sort of do an immediate retro there to identify what remediation activities we want to do across the team to help improve our overall resilience. So yeah, I kind of really enjoy it. I don't have the time, unfortunately, to drop into all of them, but I do go in as often as I can, and it's great to see the teams working on those tests.
And Neil, do you eventually, if your teams for whatever reason can find the root cause during the exercise, do you reveal to them what?
Yeah, we do. We're not that cruel. We don't let it go on too far. If it gets to the point where the chat's dying down and no one's really kind of got a clue as to what's going on, then we sort of call it at that point and do a bit of a reveal as to what we did. And then usually there's some, heads and hands type moments from the team when they're like, oh God, it's that. But it's quite fun. And I think, over time, we've been doing this now over 18 months. Over time, the number of occurrences where they don't get it has really reduced. And we've seen, quite dramatic improvements in our overall resilience and availability of the platform. And I would attribute that really to the things I've just mentioned. It's been quite successful for us. So onto non-functional tests. So here, I've got some examples on the right-hand side. These are a number of our key services, the P95 latencies from those services. I'm being very open and honest with you. Here we embed a quality gate within our software development pipeline. So this isn't like a big performance test at the end of a sprint or anything like that. It's as every PR goes through the life cycle for these key services, it's assessed for its performance based on previous runs. And if it's outside of a given tolerance, then it won't pass the pipeline check and it'll get pushed back to the developer to reassess the change. And that's quite a good quality control gate from a performance perspective, and ensures you don't sort of drift into failure over time in each of these components. So I mentioned Gremlin. So we do the big company-wide days every Friday, but we also embed via the Gremlin API and K6 in our pipeline. So this test on the right-hand side shows you a development team that have run a test against their service. In this particular test, it was 35 minutes long. They introduced initially 100 milliseconds worth of latency on pricing to the database. They then spiked the CPU to 100% on another part of the platform, the API. They introduced a complete network blockout of all traffic to the database in the 20 minutes since the test started. And you can see what the impact is kind of on the P95 latencies and the throughput on the service. So this enables us to be able to do chaos engineering at scale, and we can run hundreds of tests over multiple services in the platform, directly from the pipeline. So we found this to be quite a useful technique at being able to embed the practices in the team's day-to-day operations. Okay, so now move on to cross-region disaster recovery. So we operate active passive between EUS1 and EUS2. Our services are deployed, fully deployed into EUS2 London, but they are spun down. Our data is replicated via Aurora Global asynchronously between Ireland and London. And in the event of a disaster, we essentially drop traffic from Ireland. We divert traffic at the CDN over to our other tunnels over into London. We spin up the services. We promote the secondary databases within London to be primaries, and the same is true of Elasticache. Now the interesting thing here is, well, like, what's the lag on replicating data between Ireland and London? This is from production. You can see that the P50 lag is a mere 11.4 milliseconds. But what's interesting here, and credit to the AWS team, is the closeness of the P50 through the P99 here. We're looking at P99s of around 35 milliseconds for the replication lag between Ireland and London, which I think is quite impressive and useful data. We obviously tested this extensively before we went into production, but this is truly belts and braces, right? If you think that AWS Aurora itself replicates data into 6 availability zones as standard within a given region, but in the event of a full region outage, this data has been replicated cross-region in sub 35 milliseconds. That's quite an impressive feat, I think. So how long does it take to do a cross-region DR? So we have in our estate 114 microservices, 47 database clusters, 4 EKS clusters, some RabbitMQ and some Kafka clusters. The time to promote the secondary DBs and the Elasticache to primary is of the order of about 8 minutes. We are talking to AWS about trying to improve that time, but it's still pretty good in my view. And then the long pole in this is actually the rolling restart of Kubernetes services that is down to us really. We need to do some more optimization on our namespaces and our scripting as to how that kicks off. But end to end, that looks like it's all done within 22 minutes from the point at which we invoke the DR procedure to switch over from Ireland to London, which is a big improvement from some previous platforms that I've worked on, and really has been enabled by the tooling at AWS. When we were architecting this solution, we had a very good AWS solution architect come in and work with the team throughout the few months that we were working on this, from architecture through design into implementation, and he's still with us in terms of the testing that we've done on the platform on this, and that's proved to be quite a successful way of approaching this problem. So I'm conscious I only had a short slot, so I apologize that it's very top level here, but if you've got any questions, I'll open to them now. And if anything comes to you after the fact, then you've got my email address here, and please feel free to drop me a line directly.
Hi, Neil. This is Lloyd Altman from Ness. Quick question. For functional testing, not non-functional testing, but for functional testing, how automated are you?
Highly. So we've got, obviously, we kind of adopt the testing pyramid. We've got, I think we have a benchmark of over 95% coverage on unit test. Then in BDD and TDD activities, we've got high levels of coverage on integration tests as well. We do some manual testing for operational penny testing for when we bring new services on, in addition to the automated testing, but those tend to be when we're bringing on new providers. Pretty much everything else is automated through the pipeline.
But that's okay, and you have dashboards to measure it in a similar way that you're
Yes,
measuring.
yeah. We're very metrics driven across the org. Something like, like that, for example, that replication lag that I just showed you there, that's all metrics and alerted on. If that bumps above 50 milliseconds, we're PagerDuty'd and we get on the call with AWS.
Okay, thanks a lot. Very impressive.
Thank you.
Any more questions from the audience? Neil, do you quick question here? What is the plans for the future? And can you tell us a little bit about more, like any reconciliation process that you have happening after the cutover?
Yeah, okay. So firstly, I think, in the cutover, we obviously commit transactions down to our downstream banks and payments providers. So we have a whole host of automated and manual reconciliation activities that go on in the event of a failure such as this. And in fact, they're actually BAU, they just go on anyway. So we see if there's a difference between what we think versus one of our downstream platforms thinks. They kind of sit on top of all of this. But as to the future, one of the things I'm really excited about and would love to see within financial services is our ability to be active across multiple closely geographic regions. So, everything I talked about there is async. That's the best that we can do with the technology in AWS today. There are alternative technologies out there that enable you to, synchronously accept, and before you send the ACK back to the client, you've synchronously written to two regions before you accept the write within the scope of that single DB transaction. Now you take a slight latency hit to be able to do that, but ultimately you don't end up with that sort of worst case 35 milliseconds lag. That you are 100% consistent on the write across both regions, and that's something I've personally been trying to get AWS to do for 3 years, and I'm hopeful that at some point soon that will happen. I'm hopeful, but I think that's where the future lies. It's being able to work truly active with cross region writes across two geographically close regions. And I think when you look at, oftentimes people say to me, well, yeah, the latency hit's going to be too big, and they say, but that's going to be massive. And for certain use cases, that's true, right? But in the scope of payments, which is, as an industry, payments said that real time was sub 2 hours. And they had to coin the term instant payments for less than 30 seconds. Right here, we're talking about the scope of like 30 milliseconds. So there's an order of magnitude, difference, 2 orders of magnitude difference around that. And so I think it's fine to accept that hit for the additional guarantees that you get and strong consistency cross region. And for me, that's something I think I'm really excited for us to kind of move on to as the next thing.
Awesome. Yeah, that's a great story for sure. It'll be great to see that in the near future. Any more questions for Neil?
A couple questions. How do you mentioned a lot of third parties such as Snowflake, Datadog, etc. What's your typical integration architecture look like? Are you leveraging private link or IGW just to get out to the internet?
Yeah, kind of depends. I mean, preference is private link, where possible, not be out over public internet. We have some third parties, that require direct connect, and for the nature of some of the traffic that we do, if they're a private data center infrastructure, then we do some direct connect type work directly into their data centers. So it's kind of a bit of a mixed bag, really. But yeah, definitely private link is sort of the preference.
Great, thanks. And you also mentioned a lot of different quality control gates. But you only mentioned manual penetration testing, I believe. So do you have additional security included as automated gating?
Yeah, I mean, we have a vast array of security tools. Obviously, as part of Visa, we have a very robust cybersecurity set of policies that we work very closely with Visa's cyber team on. And yeah, I mean, that would be the scope of an entirely another presentation, but there's a lot of tooling in both the software development lifecycle for secure software development lifecycle. So things like DAST and SAS scanning, covering open source vulnerability scanning. We runtime container scanning in the environment, AWS posture management. I mean, I could go on for, there's a lot of tooling that we've got in place in that area, as well as threat detection, anomaly detection on all of our logs that come off the platform. There's a bunch of stuff in there.
Makes sense. Yeah, I was mainly interested in any of the automated gates as part of your delivery pipeline.
Yeah. So code vulnerability scanning, for example, is gated. Like, we won't accept anything below a certain severity of vulnerability that's been identified. So we've applied the shift left principles that I've talked about here in terms of chaos engineering NFT in cyber as well. Because I think that just helps. And one of the things is actually the investment in doing all this work. We obsess also around DORA metrics, and so we use Haystack to measure our software development team's performance. So we look at change lead time very closely. We look at developer throughput. We've optimized our processes around those. So one of the concerns often is you put all these tooling in, and it's like, oh, it's just going to slow us all down. When actually, I think if you look at it in the right way, it can actually speed you up, because you're not dealing with these problems later on in the life cycle. You're dealing with them right at the very onset, where the cost of change is low, and you can then still optimize the pipeline based on those are the metrics that you're monitoring through. We use Haystack, but other tools are available.
Awesome. Thank you so much, Andrew and Lloyd. Any more questions from the audience? All right. Thank you, Neil. Thank you so much.